All right, guys, we are just getting started.
Hi, everyone. Thank you for coming. I can't actually see you, um, but I can see the participant number going up. We're just going to wait like 2 minutes for people to show up. We're not going to wait too long because we do have quite a bit of stuff to show you, and we want to leave a lot of time for questions at the end. So I'm just going to wait until say 1:03 and then we'll start. Oh my goodness, we have people from all over the world today. That's amazing. All right. It's 1:03. We have about, I don't know, almost half of the people who said who'd be coming today. So I think, are you ready to start, Chris? It is recorded, so if anyone missed the first few minutes, they can always watch this. All right, so hi everyone. Thank you for joining us today. We're going to be talking about dew point, what we're supposed to do with it, what it means. My name, if you don't know it, is Angelica Isa-Adaniya or Angelica, and I'm currently the customer success manager at Conserv. Before I had this position, I was working as a conservator at the Pachacamac Site Museum in Lima, Peru. Chris Cameron, whom you see here and whom you may have also seen before in our Ask Me Anything events, which you can check out in the community, or our past webinars on capital improvements, is the principal at Sustainable Heritage, where he advises institutions on their collection environment. He previously worked at the Image Permanence Institute, IPI, has been a facilities manager, and is certified as both a project manager and as an energy manager. So we have a lot to cover today, so I'm just going to get started. Kylie, if we could get the slides on the screen, please. Are you good?
Yep, it is presenting. Are we showing
Is
it?
it?
Yep.
Okay, because I don't see it in my screen, so I'm assuming. Can everybody see the slides? Yes. Okay, perfect. So I'm just going to start. All right, so that's funny. Yeah, I can't see it, Carly. So if I don't know what slide you're on, just let me know. So agenda for today, we're going to talk about what dew point is, how we can use it to make decisions, how we can change it if we need to, and how Conserv Cloud Analytics is going to help you do this and make an action plan and look at what you're doing. So what is it? We have this one slide. I put like a fake picture of an insect because I know some of us don't like looking at insects. But essentially, we always talk about temperature, RH, things that we know are wrong. You know, we have all these different effects that we can have in collections because the RH is not quite right. You know, frozen pipes, mechanical damage, things are breaking, there are more insects, there's more mold, metals can corrode, etc. But we don't really generally talk about dew point. So today we're going to try to make this connection between dew point and temperature and RH so that you can actually start using it to make some of these decisions. So next slide, please. And I really can't see what slide we're on, so I'm sorry, I'm just guessing. So hopefully you can see a warm air giant and a cold air T-Rex in there. These are like cute little AI drawings that we made. We were trying to figure out an easy way to visually think of absolute humidity, relative humidity, in a way that's not scientific. And I will show you the scientific explanation as well, but we're going to start with this one. So let's start with absolute humidity. Absolute humidity is the actual amount of water in the air, and normally it's in grams. So grams of water per cubic meter of air or cubic foot of air. It takes into account pressure sometimes as well. So, but you can think of it as just like amount of water that is actually in the air. And then relative humidity is the percentage of the total amount of water the air can hold at a given temperature. So if you think of warm air as a big giant with massive hands and cold air as a T-Rex with two tiny hands, then you can think of them as how much water can they hold, right? So warm air can hold a lot of water and cold air can hold less water. And these are the two extremes. There are giants and dinosaurs in the middle as well. But these are the two extremes. A big one, warm, lots of water. The small one, just a little bit. So if you think of these two pictures and you say, imagine there's only 2 drops of water in both cases. If you give 2 drops of water to the giant, that's only like 10% of what he can hold, right? Like let's assume he can hold 20 drops of water. In the cold air T-Rex case, 2 drops of water is literally all he can hold. His hands are tiny. That is 100%. So even though in both cases you only have 2 drops of water, in the warm air case, you have a relative humidity that's only 10%. And in the cold case, you have a relative humidity, which is 100%. So now let's look at like the proper, more scientific way of looking at this. The text you can see is the same. So AH is the amount of water, the grams. So you can look at these buckets from the NOAA, so National Oceanic and Atmospheric Administration. The amount of water goes up if you want to keep RH at 50%, because 50% for cold temperatures is not the same amount of water as 50% RH for hot temperatures. So you can see that the actual amount of water is going up in these buckets. So I'm going to go to the next slide, please, the one with the arrow that goes up like that. And now we're talking about dew point. So what is dew point? Because absolute humidity is normally given in grams, you can't really look at grams of water in a graph together with your temperature and your RH. We have dew point, which is a temperature, and it's actually indicating how much water is in the air. So if you look at the little buckets, you can see that dew point will be the temperature at which RH is 100%. It starts coming out of the air. That's why it's called dew point. It starts forming dew. And it kind of changes, or rather, it stays stable when RH changes. So RH will be going up and down as temperature goes up and down, but dew point will help you look at actual amount of water. So if you look at the buckets, to keep RH 50% constant as temperature goes up, you're adding grams of water, and you can see that reflected in the dew point that's going up as well. So I made a little video in Conserv Analytics. So hopefully, Carly, you can play this, please. And you can kind of see, I overlaid the buckets on top of the graph. So you can see how as the temperature goes up, if you keep your RH at 50% constantly, you will see the dew point going up with that temperature sort of at the same time. And that is the indication that you have more water in that air as you're going up. Did that play? Hopefully. Yes.
Yes, it played.
Okay, thank you.
Uh-huh.
Okay, so if we go back to like the silly warm air giant and the cold air T-Rex, we look at these definitions again. So absolute humidity, let's call it the number of drops in their hands. Relative humidity is the percentage out of the total number of water drops that they can hold. And dew point is when the extra drops start falling out of their hands because they can't hold it anymore. So this is sort of like the easy explanation. You have the warmer giant reaches 100% to 10 water drops, and after that they start falling out. And for the cold air T-Rex, After two water drops, the third one starts falling out, and that's your dew point. Okay, so how is this useful for you for collections? If you want to know how much water is in your air, then dew point can be a better indicator than RH, right? Because RH is going to be changing. So thinking about dew point is going to tell you how much water there is in that space. If you see the dew point temperature going up, moisture is being added. Regardless of what your RH is telling you, what your temperature is doing, if the dew point temperature is going up, there's more water in the air. So I am going to let Chris talk about the questions that dew point can answer and what those graphs look like, and give you the more sciencey bit now.
All right. Well, welcome everybody. So we want to start with, so what are some questions we can use dew point to answer? Well, so one of the things which we've kind of briefly discussed is how much actual water is in your space, and is that water suitable for your collection space? And I'm going to give a few examples of these as we go. Is the amount of water in the air changing over time? How good is your enclosure at keeping the total amount of water stable? Basically, what happens when it rains outside? Does your space feel it? And RH and temperature are dependent. So at a steady dew point, if you were to hold a consistent dew point, any change to temperature will have the opposite change to relative humidity, or to relative humidity. So remember, if you're holding a dew point, if your dew point in your space is 45 degrees and you're changing that temperature, if you drop the temperature, you're going to increase the relative humidity. So it's good to get an idea of that relationship so you really understand how that plays to your collection space. Oh, next. So giving you, the brief description we've given of dew point, when we do assessments for sites, we like to go through and we'll use dew point for a number of things. We'll go through and try and, first thing I look at is dew point. Dew point becomes critical to me when assessing a collection space because it can tell me more about a collection than the temperature, than sometimes the relative humidity can tell me. So if I look at a collection space, one of the first things I look at is, do you have moisture control? And you may not. There may be some of you on this call who are working with a historic home or historic structure that have no form of dew point control whatsoever. You're just along for what happens outside. And this is a good way to get an idea of what happens in your space. So the outside air is, that red line on there, it's going to swing and you're going to get those, the daily, I think it's 20, 30 degree swings in dew point as we go. And you'll notice that goldish line, goldish green line there, that is our internal dew point. So we have bring in our outside air, or we bring in data from our outside air, see what's happening, and we compare that to inside. And you notice two things about this. Number one is that those swings that you're seeing outside are barely even felt inside the space. So the building structure will offer buffering to some extent. It's going to give you some buffering unless you constantly leave windows open in your space. The building envelope is going to offer you some buffering to your environment. Additionally, one other thing to notice is the dew point in this situation sits slightly higher than the outside dew point. So that's a sign that maybe the space holds a little more moisture. It's not, in the drier months, we're not releasing moisture to the air as quickly. So it's staying a little more moist. When we're at I believe a 14 degree dew point outside, we're still at about a 30 inside. So that internal structure's capability to hold moisture a little bit better is there, and it is a little evident from this graph. This helps, give a better understanding of how your structure itself just buffers for some dew point and buffers the moisture within your environment. Sorry. Next slide. But what if you do have an HVAC system? So we see, you don't have it. You'll get a little bit of buffering from that outside. But what if you don't have it? Well, when we're doing an assessment, some of the things we look at are ceilings. We look for ceilings and floors. And the ceilings, when we look at data, are going to tell me how much you dehumidify to. So a ceiling is going to be a high flat line comparatively on a graph, and that's the dew point at which you're dehumidifying to. And I'll give a graph to these in a second. And then the floor will be the flat line, a low point to how much we're humidifying to, comparative to the outside humidity. So, and when I say a flat line, I want to clarify that the graph will be a a flat dew point, a flat line dew point. It's not perfectly flat. If you usually look at a graph and it's just holding one temperature across a graph, one relative humidity, that's generally very energy intensive to perform. When we talk flat lines, we kind of prefer to see a degree or two swing. That's normal operation for a system. But when you really look at a graph and you're holding a flat 45 degrees across a graph, you're using a lot of energy to achieve that. All right. Next slide. So here's that graph. Now, not all of you will have a graph that looks like this. It was kind of made to look, it's kind of brought to look a bit extreme on purpose. So we have a flat line of about 25 degrees to where we're humidifying to. So that green line is our outside air. And you see in the drier months, the drier period, that green line is below our two points on there. So one thing I want to bring up is every air handling system, regardless of the system, will use some amount of outside air. Whether it's 5%, 2%, 10%, I've seen it go as high as 60, 80, or 100%. That outside air will play a factor within your collection space. Any moisture or lack of moisture in the outside air will play into your facility, and your mechanical system has to compensate for that. So they bring in outside air through the mechanical system, and if you have humidification, you have to humidify or dehumidify to make that air useful. So in the winter months, the dew point is lower. We bring in that air, we have to add some moisture to it. So that, this flat line lets me understand my facility's capability to humidify to. And depending on your facility, depending on your capabilities, that may vary, or you may have no humidification capabilities, and it may kind of look a little bit buffered, similar to the graph for no humidity or no mechanical system. If you see the higher line, I'll let you take the poll quickly. But if you look at that higher line on this graph, that higher line is the ceiling on this, and that is where we're dehumidifying to. So again, we're bringing in some outside air. In this point, at this part of the season, it's got a lot of moisture to it, so we want to wring some moisture out of that air. So we're bringing it across a cooling coil, and we're wringing that moisture out and stripping a lot of that moisture out to give us that ceiling. The good thing about seeing what we call a ceiling is if you look at 3, 4, 5 years of data and you see that you consistently have, in this case, a 45-degree ceiling. So you look, and every year I can expect a 45-degree dew point ceiling. It helps you better plan for your collection space. So you can then take that 45-degree dew point and go into a program like Dew Point Calculator, dpcalc.org, and you can plot a 45-degree dew point and adjust your temperature to see where your comfortable ranges are for dew point relative humidity and temperature. So at that 45-degree dew point, what are my combinations of temperature and relative humidity that I'm safe with or that I'm comfortable with? Next, sorry. Another thing that we'll use dew point for is to identify dew point signatures. And I know this is hard to believe, but in the time that I've done this in the 12 or so years, I've come across probably maybe in the 70-ish institutions, maybe about 15, 20 institutions that have no record of air handling system. I don't know what air handling unit serves what space. I don't know where this air goes. I don't even know, or they may have one random room on the other side of the building, and we don't know which air handling unit serves that room. And a lot of times you will use dew point signature to identify that. If you're data logging in all these spaces, just like every person has a fingerprint that they identify with, most air handling systems can be identified from their dew point signatures. So when we'll go through and we'll assess the space and we'll bring up multiple collection spaces, and here we have an unconditioned space. We'll have one that's a little more erratic, but we'll put up two that are right on top of each other. Now, there's some changes, and I can explain those in a second, but the fact of how perfectly they fall on top of each other indicates to me that that is most likely the same air handling unit serving that space. So it's most likely the same air handling system. If I was to see, two lines fall on top of each other, but say for one winter, they're perfect on top, but one winter, one's just significantly lower. It doesn't even line up, but then goes back to normal. That would indicate to me that it's likely probably two different air handling systems or a same air handling system with downstream humidification. So then you get into a little difference there, but it helps identify where the air is going to and coming from. And we have at times used this. We did identify in one circumstance, one room on the far side of a institution that was served by an air handling unit that served typically everything else on the east wing. So one room on the west wing that was served by an air handling unit served everything else in the east wing. And somebody had capacity, so they ran a duct over there, and it was never recorded, but it was explained why they couldn't get control over one room, because it was off by itself. Next, sorry. So when you really get to understand and really get to a better control of dew point, you can also learn to identify mechanical failures. And the image you're seeing on the right there, that's a legitimate image, not AI. Giving you the idea of dew point, that is air with a very high dew point blowing across a cold diffuser and raining inside a collection space. So just want to identify that, like, knowing what's happening in your space, especially dew point, is important because you can avoid things like that. But when you look at dew point, you can identify things like a slow dew point climb. I mentioned a second ago that you can look at dew point over a few years, and say 2 or 3 years, and say, okay, I'm doing a 45-degree dew point. I know what I can plan for my collection space. Now, I have worked with an institution that while we're working with them, we bring up their data, and they were on record as having a 45-degree dew point. We know we can do that. But over a period of 5 years, they are no longer at 45 degrees. They were at 45 degrees. The next year they were at 47, the next year 49, the next year 52. Long story short, after 5 years, they're putting out a 52-degree dew point. So that, looking at that, that's indication to me that their cooling coil was failing and no longer capable of providing a condition for them. So that's a sign for them to go to the facilities and say, hey, we started off at this condition and we're slowly failing. And they didn't look at dew point. They were trying to explain why they can't, they couldn't hold the conditions they recommended. We rounded, this temperature, this relative humidity setting, but now 5 years later, this temperature is giving us a much higher relative humidity, and it's not stable for our collection. And the reason for that was the cooling coil was failing, and they weren't looking at dew point to identify that. Dew point when you look at dew point, there's some other things you want to look for, giving some more information. Sorry. If you see a sudden spike on something, that is usually indicative of a failure or a fix. And I say that as a drastic change or a fix. Typically, if you see something spike up, whether it's temperature or dew point, that generally means something was changed. A set point was changed, something was adjusted, a mechanical system was turned off, or a mechanical system was turned on. And if you see something slowly climb up or down, that's usually a sign that something's slowly failing. If you're looking at dew point and again, it's slowly climbing up, you could be losing your cooling coil. If it's slowly climbing down, that could be a sign that the humidifier is failing, sorry. It's just a good indicator. So a quick spike up, somebody's working on a system, making changes, making an adjustment, and a slow climb may be indicative that something is failing. Oh, next. So now you get an idea of, some things to look at for dew point. How do you change it? So when you think about dew point, there's only 2 ways to change dew point. And some things I want to clarify, just verbiage, is when you talk to mechanical people, in the mechanical world, those 2 words is sensible and latent. And when they talk about changing temperature, just room temperature, walking up and hitting the temperature up or down on your thermostat, that's called sensible change, where sensible heating, sensible cooling. It's the sensible is the temperature, just temperature change to the space. When we talk about humidifying, dehumidifying, and adding moisture in the HVAC world, they talk about latent. So latent refers to changes in moisture in the air as well. So latent is going to be, if we humidify, we're going to add moisture to the air. And if you dehumidify, you're going to remove moisture in the air. So I want to really just make sure I drive that home. So the only 2 ways to really truly adjust the dew point is to either humidify or dehumidify. And I'll give just two quick examples of that. So first of all, this is humidification. That is the beautiful chaos of an operating steam humidifier. So when you humidify air, there's generally 3 ways we can do that. We can either do it through a spray system, which is going to be a system where they will pump water through these little jets into the air. Or in this case, where they steam the air, they're actually heating water to, I believe it's 210 degrees, and then pushing the steam down into the pipes. So you don't really want to stay and you go anywhere near the system because you could get burned easily in that type of scenario. But I want to put that image up to give you, a lot of people have asked in the past, what does it look like to humidify the air? And that's it. There's also adiabatic. Those of you in dry summer climates, Colorado area, maybe some parts of California, Arizona, have what they call adiabatic. And adiabatic is passing airstream over a source of moisture. In a lot of instances, it may be a screen that is soaked with say water, and the air that passes over that screen will pick up that moisture. So it will not only be cooled, it will actually add moisture to the air as it goes over. Which is called adiabatic cooling or adiabatic humidification. And then there's also adding outside air. And yes, there are some times when it may be too dry inside, but perfect outside, and we'll bring in some more outside air to increase those levels. Next. And then we have our dehumidification. So I don't have a wonderful video to go along with this. Dehumidification isn't as fancy and wonderful as humidification. But dehumidification is usually performed in 3 different ways. So you have the chilled water coil, which is similar to what you'd see on the right there. Basically, a chilled water coil is going to operate very, very similar to a can of soda that would be in your refrigerator on a hot summer day. You take that can of soda out, you bring it outside, and the temperature of that can of soda is below the dew point of the air it is in. And that's the important. The object has to be below that dew point. So the can of soda is below the dew point of that air, and the condensation starts to occur. So looking at that, the chilled water coil is essentially performing that task. The chilled water coil is the tubes with fins on them, and they're bringing that coil below the temperature of the coil below the dew point of the passing air, and they'll use the fans to push the air across, and the condensation will occur on that coil, and then they'll just pipe it out of the system. So it essentially works very similar to how your soda can works on a summer day. You can also have a desiccant system, which I'm sure many of you on this call have, which is essentially a desiccant material that's in a rotating wheel that will draw moisture out of the air as it passes over it and then be regenerated and reused. I think it can last about 7 years, that little spinning wheel. And desiccant wheels are great for getting very low temperatures. You can get below freezing temperatures sometimes, depending on the type of desiccant system. And lastly, there are dehumidifiers, which you all know what they are, and I won't go off on my rant about them, but there is some blog post that I posted previously on Conserv about my hesitations and restrictions, I will say, on the use of dehumidifiers for collection spaces. I'll save you all that rant today. Next. So one of the last things I want to talk about are exhibit cases and storage furniture. So one of the first things I mentioned when we opened was, okay, you can use a dehumidifier, or you can use a dehumidifier. You can use a case or your building, or you can use your data and look at your building, and understand how your building can buffer from the environment. Similar to how your building can buffer, you can use cases, vitrines, cabinets, even in some cases I've seen safe, which I'll discuss in a second. You can use cases, and at times even your compact shelving will buffer from the surrounding environment. And you can really see that in some instances. If you look at dew point for collections, you're in a historic house, you don't have great ways to buffer. Sometimes you might be able to pull it off using storage furniture. So, looking at that dew point, what kind of buffering does this case offer? How slow are the changes felt? How much does it offer? Gives you a really good idea. Is that case offering me some protection? Next slide. So this is just one example, and this is just an example I have here. So we have 3 sensors. So you have a red and blue sensor, and a red and blue sensor, and that little teal sensor across top. 3 of the same loggers. 3 loggers in the same space, sorry. And it's not a very large space, but they're close to each other. So one is in the case. Then I'll give you a guess as to which is in that case. But one of these data loggers is in a case. So here you see the 2, say the red and the blue. They're almost on top of each other. And if I go by the same rant I gave earlier about dew point signature, I would say they're most likely the same. Not even so much they're not on top of each other, but by the fact that all the peaks and jumps and ups and downs are all the same. So that would lead me to believe that's most likely the same logger. And at times like this, the fact that they're about a degree or two off leads me to believe it's logger calibration is the only reason that they're not on top of each other, that they don't agree. So this is the same logger, same room, or same air handling unit, same room. Why is the teal different? And the teal's inside of a case. The case is providing me a nice buffering from the environment. However, in some instances, it also is a detriment. So where I'm using that case to buffer from the environment, I have seen instances where that case was in a wooden cabinet that was over a vitrine. And that vitrine that culvert. It was over a culvert that was moving water outside of the building. It just happened to run under the case. The culvert was transferring that moisture up into the space, but unfortunately, unknowingly, the wood case was above it and trapping the moisture inside. The staff didn't know that. Once we see that the dew point was high, the room was low, that leads us to believe the moisture is coming from somewhere, and we started to break down. What could be our source of moisture was actually coming through the floor. So it helps you identify scenarios like that. And, going back to historic homes, there is a report, I believe the Morris County Parks Commission did a study, and they used a safe they used a safe in a historic house, and they retrofitted it with some gasketing and even a wooden cabinet, and they were able to get really good buffering from the environment for their collection, even in a historic house, by retrofitting a cabinet. So they had the outside air, and they used the house itself as a first layer, like box and box, and then the cabinet itself for the second or next layer buffering. So it gave just an extra layer of buffering and an extra way to help condition the air or protect the collection. So I pass you back over to Angelica who will take you through the rest of.
Yes, thank you. So I'm just going to show you a couple tricks here from the Conserv software so you can actually start looking at dew point in the software. So this right now, for example, is where you can actually grab the dew point for a lot of different number of sensors and put them on top of each other so you can look at these dew point signatures that Chris was talking about. So for example, here it's pretty obvious. These are all here. And you can tell actually that the three ones that are going up and down a lot at the top are pretty much in the same space for me, except that dark blue one was outside briefly. So you can really see when I put that thing outside and when I brought it back inside the closed building. And then you can see a completely different dew point signature at the bottom, and that's because I have a sensor in the freezer. And you can actually see that those massive dew point spikes there where I was taking the sensor outside of the freezer for some reason or another. So this is the kind of thing that you can do. You could just grab a bunch of dew points, put them on top of each other, and start looking for those dew point signatures, identifying where your different AHU units are servicing, etc., straight on the analytics in Conserv. Next, please. Right. And this is another thing that you may or may not be using right now, which is observations. All you need to do is right-click to add an observation. You can put in a name, a description, scope, meaning, does this apply to the location or just to this particular sensor? Does it have a start time? Does it have an end time? You can add a picture. The reason observations can be really valuable for all this dew point investigation that you might want to start doing is that when you see these spikes or troughs today, if it just happened recently, you probably will know why that spike is there. Now, as time goes by, if you didn't write that down anywhere specific that you know where to go, over time, you won't remember what that is anymore. If you're looking for these floors or ceilings that Chris was talking about, if you've identified them at a certain point in time, it's not a bad idea to add this observation so that in the future, you can just go back to that and then you don't have to be thinking like, oh, I know we realized we had water coming in, but I don't remember when it was. If you add an observation, it'll be right there on the graph. You'll be able to go back to it directly and specifically. Next, please. And then the other section of this is the comments. I don't know how many of you are using this. I think some of you are, I've seen it, but it can be very valuable when you have team members on your account, especially if you have team members from facilities or operations. If you can have these common conversations essentially with the observation, with the description, so you can actually start talking about what might be going on here, and then you will have a history over time of the different observations you've been making, and this could actually help you sort of manage your spaces a little bit better. Next, please. All right. And this is essentially our final slide before we start going into questions. I see some questions are coming in. Melissa is our dew point queen. She likes making these dew point stumpers. And the reason is that dew point can be confusing. If this is the first time you're sort of running into and you're still sort of, becoming familiar with the concept of dew point, what it means, what it looks like in real life, it's really useful to sort of see dew point in real life. Like, for example, in this fridge that she saw in a store, and think about what that means. Why is that dew on that surface? Is it on the inside? Is it on the outside? What's going on? And thinking about it in all these different ways can really sort of help you over time wrap your head around dew point, and then bring this knowledge and of the system, of the dynamics, into your collections care practices. So if you go into the Conserv community, and then there'll be other people there with a lot of experience, you'll be able to have a conversation with them about these. You can just search for dew point stumpers on there, and you'll see all these threads that Melissa has done that are really great. So we're going to open for questions now, because I know we've gone through a lot, and there is a little QR there. If you want to download these slides, you definitely can. And we just did a final poll to see whether the beginning and the end of when we asked you how much you knew about dew point has changed after today. Hopefully we've helped. I might just read these out. I see one question from Dale. Let me see.
We also
Yes.
have Eva, who raised her hand, and I can let her talk if we want to. Eva, quickly in the chat, just say, yes, I still want to talk, or whatever. You can address Dale's comment, and then I'll turn Eva on if you want.
Okay, sure. Chris, I don't know if you can read Dale's comment, but I'll read it out for everyone just in case. So in a room or a case or a cabinet, if dew point goes up, there are additional water molecules entering this space. If the dew point I'm assuming if the dew point goes down, water molecules are being lost. The question always becomes, where are they coming from, or where are they going, and are they going or coming quickly? That seems to me to help a great deal in identifying normal operating conditions for a space, or an irregular or failing feature of the space. Adding an observation to the trend is a great way to indicate a known or even an unknown cause. Thank you, Dale. Thoughts, Chris?
There we go. Sorry, wouldn't go off mute. No, I definitely agree with that. Being able to share that observation with others as well, others within your team as well, it would be good. We've being able to what you see, and I guess forward it on to a facilities person or a representative for facilities to get their why is this occurring? Do you know why this may be occurring? Would be a huge benefit as well.
Yes, we have another question from Susie. Can some HVAC systems be set to a dew point, or is it just a matter of managing the humidity kind of by hand?
Okay. In my opinion, my experience, not my opinion, a lot when you deal with winter months, a lot of HVAC techs look at winter season in relative humidity for programming. And when they talk about dehumidification, they do talk about dehumidification. The ones I've worked with, I've talked about dehumidification in the realm of dew point, because they want to bring it down to a dew point and then set your temperature and relative humidity after that. And they do that because more it's the operation and design of systems. The air handling systems are typically designed to humidify to a relative humidity point, and they're designed to dehumidify to a dew point. Like I said, the cooling coil, you can look up what the cooling coil was designed to, and it'll tell you, it was designed to achieve a specific dew point or use chilled water at a specific temperature, which gives us an idea of the dew point that system's capable of. So it depends on what the season you're in and who you're talking to, but you can use, most of the time dew point is a good way to go. But a lot of, maybe it's hit a scenario like drier seasons where you want to talk about, using relative humidity, just because that's the term used at that, for that type of system.
We just got a really good question. How do you make friends with your HVAC staff? Because apparently some HVAC people are a bit territorial about their systems and their numbers.
They can be very territorial. I made the joke one time that, so I currently, when I'm not consulting, I am assistant director for a facility management team, and I have a crew of I think 22 staff now that work under me, and you buy them donuts and they will pretty much do anything for you. Just, I mean, and I'm saying that humorously, but be friendly with them. A lot of, show them your collection, bring them down and show them, what you have there, why it's important. Get their input. Give them a little tour of your collection, show them some of the, the important objects, ask to see some of the mechanical room, let them know, you're working together because, some of the ways there are sustainable practices that we can implement in mechanical systems, and we can reduce energy consumption while at the same time improving your collection environment. So it's win-win. You're helping them reduce the energy consumption and look better by doing so. At the same time, you're improving your environment for your collection. But end of the day, just, be friendly as possible. Any of my staff, if you were to, treat them to something nice, I've made the joke, they'll help you hide a body at the end of the day. And it'd be amazing what a donut can do.
Yeah,
You feel
Susie
like-
says, sorry,
ahead.
go.
I was just gonna say, I live in the South where it feels like it's humid all year long. And Angie or Angelica lives up in Canada where it's a very different climate. Do you feel like there's standards for each different area, or is it a totally unique experience for every place that you go, every conserving or collection space?
For the facilities team,
For dew point control.
or for it'll be different for every facility I'm in. I mean, I've seen places up north that have phenomenal, dew point control, places down south, but I've been to places in the same city that have night and day controls. One's got phenomenal HVAC system, and the other just has a system installed probably 60 years ago and is just limping along. It really all comes down to, what was installed and who was thinking what. And a lot of times, I'll go back to facilities. They may be dealing with an archaic system. So touching backwards, I apologize. Someone had asked me one time, how do I communicate better with my facilities? And I said, okay, tell me a little bit more information. They said, well, my facilities person, I repeatedly will go to them with suggestions or problems, and they're not answering me. I said, okay, next time you reach out to them, send me a copy of that email. And they did. I printed it off. It was 6 pages printed. And bringing that up to tie to some of what you had just mentioned, a lot of mechanical systems they're working with are old. I do have 20 staff that work underneath me, and 20 staff are managing 500 facilities. So I have some staff that will be, across a county in a day. It's a very large footprint. They're handling all kinds of equipment, and we don't know what kind of mechanical systems they could be managing. They could have their hands full. So you want to make sure we're keeping communication concise, because we don't know, get to the who, what, where, when, and why on a problem. But at the same time, try and be mindful, because you don't know if they're dealing with archaic equipment that can't get there. Try and talk on the same level, because I have seen people requesting conditions that their mechanical system will never achieve. And they'll tell me, I talked to the facilities and they're just not working with me. Well, we look at their conditions, and their mechanical system will never get to the conditions they're requesting. Just was never capable of it. And there was a reason facilities was kind of almost feeling pressured to achieve something unachievable. And just, again, it's just making sure everyone's on the same level with that. Sorry, I didn't mean to kind of bounce back and forth on that.
I have a question, Chris. So what happens? So we're talking about, HVAC and facilities, but obviously, not everybody has that. Some of us just have nothing, right? And when we're talking about dew point, we're talking about you're either adding moisture or you're taking moisture. How do you do that in a way that is safe? Because you know how humidifiers can turning things on and off every day, especially when you're like on a 9 to 5, can just make things worse. Like what kind of things can we do to make this work when there isn't a mechanical system?
Okay, dehumidifiers, I'm not, dehumidifiers can be a necessary evil. There are times when, yes, you do, I'm not a fan of them. I will never advise to use them in a collection space unless it's really kind of a last ditch effort. There is no other option. And even then, there are commercial dehumidifiers, which I would lean a bit more towards, preferably. I'll give you my very brief, grandstand on that. Dehumidifiers, residential dehumidifiers, the kind you can go into Lowe's, Home Depot and buy, have a history of issues, problems, recalls. There's traditionally every year, 2 years, a recall on those. And it makes me hesitant. A couple of years ago, the recall that was going on, there were a number of fires that occurred because of them. So just the concern of them happening in a collection space, I just really the last thing I want to avoid. But there have been scenarios where it has been something we've had to recommend. But again, there are commercial dehumidifiers you can buy. They can be expensive, about $1,000, even through Amazon, but you can get those, and they are very good at drying a space out. They're unsightly because they're huge, but they can dry space out. Humidification's a little trickier. The humidification, we were actually just talking about a similar scenario just before the call. You can get little localized humidifiers, but the problem with things like that is you may get a localized humidifier, a little pot blowing off steam into a space, but it is just that. It's a localized humidification, localized moisture add. And unless you're actively moving that around the space with a fan or an air handling unit, it's going to have just almost uh, microclimate effect. You're just going to have one maybe corner of the space that could have a higher humidity because you're not forcing that moisture around the room. So um, having that, adding moisture is a little bit trickier when you're not moving that through a system. But you can use dehumidifiers a little bit easier in that respect. Typically because dehumidifiers have a strong fan that they're pushing the air around the room with.
Right. How do you feel about like opening windows and opening doors and closing things? Because, sometimes that's just the best you can do. Was that like something you can see in the dew point and then you can sort of like play with how often you're opening this door or this window at different times of the year?
Yeah, so I have a historic farmhouse, and not historic, but I have an old 180-year-old farmhouse. And we actually have used that technique in our house. Like we have a whole house fan. And there are times when you use the doors of your house like a damper to move air one way or another. And at times I've even opened the basement doors and run the fan with the basement windows open to pull the moisture and the cool air from the basement through the house on a hot, dry summer day. So there are, that's an extreme example, but yeah, depending on the scenario and how you want to move doors. Doors can also be your enemy because a lot of times in and not even historic structures, in institutions in general, we remodel the buildings. The space never stays the same for a long period of time. We want to add a gallery, we want to change rooms, we want to adjust something. And is a number of times that the air movement, the air conditioning in that space is not considered in that. And I have seen a wall put up in the middle of the room with the diffuser on one side and the thermostat on the other. And now the thermostat's in a room with no diffuser, not getting any air, but and they're like, well, we can't control this room. Well, you can't control this room because the control's in a whole nother room that for some reason nobody moves. So yeah, sometimes walls and doors can be your enemy if it's not the movement around the space is not considered.
All right. Well, does anybody have any other questions? I think I see one in the Q&A. Does it change the dew point when you use a fume hood or a trunk extractor?
So all the fume hood, the best way to understand those devices is just assume that they're exhaust fans. All you're doing is just pulling air out. The only way that that could truly affect your dew point potentially is if there's the air handling system should just, if you turn the fume hood on, depending on your system, may just have to draw in more outside air. The system still should compensate for adding or removing moisture based on the use of the fume hood. So it shouldn't matter using the fume hood. However, if you don't have a mechanical, if you don't have, your mechanical system can't add moisture or can't remove moisture or lacks those capabilities, using a fume hood, you may see, depending if there's a rainstorm or, something going on outside, you may gain some moisture or lose some moisture, but overall, the using that for the short term shouldn't really affect you. Shouldn't have that great of an effect.
And Melissa's got a question about whether pressure changes impact the dew point temperature, because we know, I think pressure changes do impact RH to a certain extent, right? But what about dew point?
That's I was having a conversation yesterday with someone. The air wants to go from high pressure to low pressure. So yes, you can, depending on pressure changes, that can be an issue. And we've seen that occur. I've seen that occur in a few instances where in a lot of times that'll happen if the dew point on one side of a room is significantly higher than the dew point. Like one room has a higher dew point than another, and there's a very poor vapor barrier. Yes, that pressure can help push the moisture through to the other space. And in some instances with poor vapor barrier, it'll go right through the walls. Not quickly, but it'll go through the walls.
Wow. That's really cool.
Yeah, it's not fast. It's a very slow process, but it'll happen.
All right, we have another question. It's a specific case example. She says, or they say, I have a vitrine that was getting moisture on specific sides internally and the corners. I added a data logger and the dew point was around 40 and the RH stayed around 64. The temperature was between 50 and 70, and they couldn't understand why the moisture was forming inside. This is like a dew point stumper, I think. So it's an anonymous question. So I think we could also put this in the community and we can have a big conversation below.
I was just about to say.
Yeah, the case is next to a window, but the other cases didn't have this.
Yeah, I mean, there could be that's one of those things that I kind of want to see all the factors that play into that. Because there could be, you could have moisture leak through the window. There could be a number of things that play a factor into that I like to get an idea of, because it's never usually like one specific detail. You kind of want to walk in and look and say, okay, you've got this, you've got this, you've got this, and get the layout of everything in the room and the air handling system to get to understand of like what could be causing that problem. Unfortunately, it's hard to answer those without seeing all factors playing into that.
Yeah, maybe getting a little graph of what's going on in each of the different cases, what's going on outside to see if there's any visible.
So one of the best examples I ever got was from Jim Riley, who was the director when I started at IPI. So Jim was working with an institution and they saw the dew point spike on the graph every night at 10 o'clock, and no one understood why. There was no change to the mechanical system, but there was a dew point spike of like 3, 4, 5-ish degrees every single night at 10 o'clock. And it was a stumper to everybody. So Jim had started working with this institution. This was his favorite story. I had heard it about 4 or 5 times when he was working at IPI. And he had given me this, okay, so what's happening? Well, he went to the institution that night and stayed that evening with the director to try and figure out what's happening. And lo and behold, the cleaning crew at 10 o'clock every night wasn't just mopping the floor. They were dumping buckets of water on the floor. And that was how they started. They would come and dump the water and then start mopping that way. And it was that moisture, like I say, the adiabatic effect, that introduction of moisture to the space was being read on the loggers.
Right. I thought you were going to say they were making coffee at 10 p.m. every night or something and setting the kettle on.
I was going to say, which goes to a whole other thing. I have, make sure your loggers are in good locations, because I have seen data loggers in a lab, and the lab had a coffee pot and the logger was above where the coffee pot was. So you could get some false readings from, any false source of moisture or anything. So just make sure you have some good you have them in good locations.
Mhm. We have a comment from Sue. So she said she spent a summer in Washington, D.C. years ago. The AC where she was staying died a few days into the stay. Luckily, the house had an amazing attic fan, which made the heat and humidity bearable. So all she had to do was turn on the fan and open the window downstairs, and that made the air pull through the house, like just
Yep.
like that. So yes, that's a very nice way of
Yeah,
using the
just
building and
understanding
a
the way the
fan.
flow, especially a lot of historic structures, were built. The people that built them really understood the air movement and how to alleviate that. So I have 9-foot ceilings in my house, and my windows are on my first floor are 8 feet tall, and they're double hung. So
Mhm.
they intended, there's a lot of windows on the east and a lot of windows on the west, and they intended to on a nice day with a nice breeze, raise the lower windows on the windward side and drop the high windows on the outward side, so it would blow in and push the hot air out the
Just go.
top.
Yeah,
So
that's
when you understand like some of the features that are built, a lot of them knew what they were doing back then.
yeah. So actually, for those of us in old historic buildings, maybe we are better off than we thought. Maybe we're just trying to do, maybe the building's already built to do something great.
Yeah.
So it's just
Sometimes,
a matter of finding out.
sometimes when we seal them up, we kind of trap issues.
All right. We're very close to 2 p.m., which is the end, or 2 p.m. Eastern for us. Very close. Does anybody have any last questions? I think people are starting to drop off.
I do want to quickly just let people know that that QR code does take you to a landing page that has more resources on it for Dew Point and some of Melissa's Dew Point stumpers, things like that. So feel free to use that. And if you are in the community who still has questions, still has things that you need help with, please don't hesitate to reach out to us. We would be happy to talk to you. You can email us at team@conserv.io or go to our website. There's a bunch of ways to get in touch with us.
Yes, and this is recorded, so we will be posting this in the community as well, if you
Yes.
missed any minutes of it.
We really appreciate all of you guys for coming.
Yep. Thank you, everybody.
Thank you.